Leucovorin is one of those medications that sounds mysterious, complicated, and a little intimidating. It gets mentioned quietly in medical settings. It shows up in cancer treatment conversations. Parents sometimes hear about it in relation to neurological or developmental conditions. And because it is not a drug most people encounter in everyday life, it often comes with confusion and questions. What is it exactly? Where did it come from? Why was it created? And what does it actually do inside the body? Today, we are going to walk through all of that slowly and clearly. This is not medical advice, this is an explanation. The goal is understanding, not persuasion. And by the end of this video, you should have a solid mental picture of what leucovorin is, how it works, and why it has remained medically important for decades. Let us start at the beginning. Leucovorin is not a vitamin. It is not a supplement. It is a medication that is closely related to folate, which is one of the B vitamins. Folate is essential for life. Every cell in your body depends on it. You need it to make DNA. You need it to divide cells. You need it to produce red blood cells. You need it for brain function. You need it for growth, repair, and maintenance. Without folate, cells cannot properly copy themselves. And when cells cannot copy themselves, tissues fail. Leucovorin is a form of folate, but not just any form. To understand why leucovorin exists, you need to understand something important about folate itself. The folate we eat in food or take as folic acid supplements is not immediately usable by the body. It has to go through several chemical steps inside the body to be converted into its active form. Think of folate like raw ingredients. Before the body can use them, they need to be processed. That processing happens through enzymes. Enzymes are like tiny machines that perform chemical jobs. One of the key enzymes involved in activating folate is called dihydrofolate reductase. This enzyme takes folate and converts it into a biologically active form that cells can actually use. Now here's the crucial point. If that enzyme is blocked, folate cannot become active. And this is where leucovorin comes in. Leucovorin is already in an active form. It does not require that enzyme to be useful. It bypasses the blocked step. That one property is the entire reason leucovorin was invented. To understand how that happened, we need to go back to the middle of the 20th century. In the 1940s and 1950s, cancer research was rapidly advancing. Scientists were learning that cancer cells divide very quickly, faster than most normal cells. And that gave researchers an idea. If you could block cell division, you could slow or stop cancer growth. Since folate is essential for making DNA and dividing cells, scientists realized that blocking folate metabolism could slow down cancer cells. This led to the development of methotrexate. Methotrexate works by blocking the enzyme that activates folate. Without active folate, cells cannot make DNA. And without DNA, rapidly dividing cells die. This was revolutionary in cancer treatment. But there was a problem. Methotrexate does not only affect cancer cells. It affects all rapidly dividing cells. That includes cells in the bone marrow, the gut lining, the mouth, and the immune system. Patients experience severe side effects, mouth sores, dangerous drops in blood counts, intestinal damage, sometimes life-threatening toxicity. Doctors needed a way to protect healthy cells without protecting cancer cells. That is when leucovorin was developed. Leucovorin was designed as a rescue drug. It is sometimes literally called leucovorin rescue. After methotrexate is given, leucovorin can be administered to supply active folate to healthy cells. Because leucovorin bypasses the blocked enzyme, it allows normal cells to recover and survive. Cancer cells, however, are often less efficient at taking up leucovorin or are already too damaged by the methotrexate. So leucovorin selectively rescues healthy tissue while still allowing methotrexate to do its job against cancer. This was a major breakthrough. It allowed higher doses of methotrexate to be used more safely. It made chemotherapy more tolerable, and it saved lives. That is the historical origin of leucovorin. It was not created as a supplement. It was created as an antidote. Over time, doctors realized that this rescue effect could be useful in other situations as well. Leucovorin began to be used for methotrexate toxicity. If someone accidentally received too much methotrexate, leucovorin could reduce harm. It also began to be used in certain types of anemia related to folate deficiency. Later, it found a role in combination cancer therapies, particularly with drugs like 5-fluorouracil. In that context, leucovorin actually enhances the effectiveness of chemotherapy by stabilizing drug binding in cancer cells. So, depending on the situation, leucovorin can either protect cells or help kill cancer cells more effectively. That may sound contradictory, but it makes sense once you understand the chemistry. Now, let us slow down and talk about that chemistry in plain language. Your body runs on chemical reactions. Many of those reactions depend on small molecules carrying pieces from one place to another. Folate is one of those carriers. Active folate carries tiny chemical units called methyl groups. These are needed to build DNA and other molecules. Inactive folate cannot carry those units. The conversion from inactive to active folate requires that enzyme we mentioned earlier. Leucovorin skips that step. Think of it like this. Imagine your body needs electricity to run machines. Normally, electricity comes through a transformer station. If that station is shut down, the power stops. Methotrexate shuts down the transformer. Leucovorin is like a backup generator that feeds power directly into the system. Because of that, leucovorin keeps essential processes running even when the normal pathway is blocked. That is why it is so valuable. Now let us talk about how leucovorin is used today. Its primary use is still in oncology, cancer treatment, chemotherapy protocols. It is commonly used with methotrexate and with 5-fluorouracil. It is also used in cases of accidental methotrexate overdose. In some rare metabolic conditions, leucovorin may be used to bypass folate metabolism problems. And in more recent years, it has been studied for neurological and developmental conditions where folate transport into the brain may be impaired. This is where you may have heard about it in discussions involving autism or certain neurological syndromes. Here it is important to be precise and careful. Leucovorin is not a cure. It is not appropriate for everyone, and research in these areas is still developing. But the scientific logic behind its use is consistent. If the brain is not getting enough active folate due to transport or metabolic issues, supplying an already active form may help restore function in some individuals. That does not mean it works for everyone. Biology is complex, responses vary. But the reason researchers are interested in leucovorin is not random. It is based on decades of understanding how folate works in the body. Now let us address a common question. How is leucovorin different from folic acid supplements you buy at the store? Folic acid is an inactive form. It must be converted by the body. Most people can do this easily. Leucovorin is already active. This matters in situations where the conversion process is blocked, impaired, or overwhelmed. It also means leucovorin is a prescription drug. It is dosed carefully. It is monitored. It is used in specific medical contexts. This is not something to self-experiment with. Another common question is about safety. Leucovorin has been used for many decades. Its safety profile is well studied in medical settings. Side effects are generally mild, but like all medications, risks exist. Those risks depend on dose, context, and the condition being treated, which is why any use of leucovorin should be supervised by a physician who understands the underlying reason for its use. So to summarize what we have covered, leucovorin is an active form of folate. It was invented to protect healthy cells during chemotherapy. It works by bypassing a blocked metabolic step. It has been used for decades in cancer treatment. It plays roles in managing drug toxicity in certain metabolic conditions, and it is being explored in neurological research where folate availability may be disrupted. At its core, leucovorin is not mysterious. It is a tool, a very specific one, designed for very specific problems. Understanding it does not require a chemistry degree. It just requires understanding pathways, blocks, and bypasses. And when you see it that way, its role becomes much clearer. If this explanation helped you understand leucovorin more clearly, please consider liking this video and subscribing to the channel. It helps these educational conversations reach more people who are trying to make sense of complex medical topics. And if you have questions or want future videos that break down medications or treatments in plain language, feel free to share that in the comments.